Hey guys, welcome to the first video on nth roots and rational exponents. To start off, we're going to talk about nth roots and how they relate to rational exponents. So we've already looked at nth roots and we understand the parts of an nth root. As a refresher, we have the radical, which is this symbol here. This n, the number written here, represents our index, or the nth root. And what's inside is the radicand. So we've got index, radical, radicand. When we start looking at nth roots and how they relate to rational exponents, we can look at the relationship as this. An nth root of a is the same thing as writing a to the 1 over n. So we can change a radical, or a radical of an nth root into a rational exponent, or an exponent that is a fraction. This is equivalent to saying, this is the same thing as saying, if 2 cubed is equal to 8, I can take the cube root of 8 and get 2, or I can take 8 and raise it to the 1/3 to get 2. So these are going to be equivalent statements. So if I'm using this definition, the nth root of a is equal to a to the 1 over n, I can go back and forth between nth roots and rational exponents. So if I have the 6th root of x, I could rewrite this as x to the 1/6. Or if I have the cube root of b minus 2 is under the cube root, so this will become b minus 2 to the 1/3. Similarly, if I have something like y to the 1/7, I went forwards here, I can go backwards from a rational exponent to an nth root and write this as the 7th root of y. Or if I have c to the 1/4, I can rewrite this as the 4th root of c. So it's really all just depending on how I want to look at my radical, or if I want a radical or a rational exponent. So now that we have this down, we can extend it because we understand things about exponents. Because I can write a radical as a rational exponent, all of the exponential properties are going to apply. So that means a to the m times a to the n is equal to a to the m plus n. A to the m over a to the n is equal to a to the m minus n. Or you can gather these from your previous notes. One thing that I really want to point out, a property that does not exist, is this property here. If I have a binomial or any polynomial greater than a monomial raised to an exponent, I cannot distribute the exponent in. That's really important here that we remember that in this section. So I have all of these exponential properties that can apply. So if I take my exponential properties and I add them to what I already have here, my definition of a radical or a rational exponent, I get this. I can take the nth root of a number raised to an exponent and rewrite that as a to the m over n using my, I can get from here to here using my properties of exponents, right? I can go from, I can go from the nth root of a to the m becomes a to the m raised to the 1 over n. Using my exponent rule here, this becomes a to the m over n, which, using this same property but working backwards, I could rewrite as a to the 1 over n raised to the m, which would become the nth root of a raised to the m. So basically, I've just worked through going from this nth root to a rational exponent and back to this nth root. So I can use this in a lot of different ways. So what we're going to look at right now are a couple examples of how we might work through these. Those are going to be on the next video.